Hello and welcome to this video for the 2022 Level 1 Mathematics and Statistics MCAT. So this is the algebraic paper that's given to Level 1 students every year and is marked by the school. So we're going to jump right straight into it, to question 1. And just to note, this paper, we cannot use a calculator. So to abide by those rules, I won't be using a calculator when I go through this paper either. So this is a purely written paper, no calculators, no nothing. So just keep that in mind. So question number 1, we'll look at question I. Find the perimeter of the right angled triangle shown below. We want to fully simplify the expression. So the perimeter of the triangle will just be the sum of all three of its edges. So it will just be the sum of all the edges we see here. We have x minus 3, so we have p equals to x minus 3 plus 2x minus 5 plus 3x squared plus 5x plus y. And we're just going to add the like terms. So we have p equals to 3x minus 8 plus 3x squared plus 5x plus y. And that equals to 3x squared, 5x plus 3x is 8x, so plus 8x plus y minus 8. And that should be it for this question. So we simplified fully. And this should be a achieved level question for a correct answer. Question II. If the area of the same triangle shown above is 3 centimeters squared, then find the value of x. So it's told us that the area of a triangle is half the base times height. So we know that the total area is 3. So we say that area is equal to 3. That equals to 1/2 times some base, which is given as 2x minus 5, times the height, which is equal to x minus 3. And now we just need to solve this quadratic equation. So first we're going to multiply both sides by 2. So we have 6 equals to 2x minus 5 times x minus 3. And now we're going to expand the right hand side. So we have 6 equals to 2x squared minus 6x minus 5x plus 15. And therefore we have 6 equals to 2x squared minus 11x plus 15. And now we can subtract both sides by 6. So now we have 0 equals to 2x squared minus 11x plus 9. Okay, and now we need to either use the quadratic formula. So in this case, in level 1, we have not learned the quadratic formula. So all of these equations given in level 1 should be able to be factorized into very neatly into whole numbers. So that's what we're going to do. And for this video, I'm just going to introduce a very neat trick that I found that we can factorize something very easily. So in general, there's multiple ways you can factorize. And probably if you want to just do really quickly, guess and check, that's probably okay. So you can guess and check using the factors of 2. So we have factors of 2 is only 2 and 1. So it has to be 2x something and multiplied by x something. And now you're looking for two numbers that multiply to 9 and add to negative 11. But that guess and check can take some time. So I'm going to introduce a new method that will always get you the right answer. So there's no need to do the guess and check. So the first thing we're going to do for this method is going to consider the coefficients of this polynomial. So we have a polynomial, let's say p of x is equal to ax squared plus bx plus c. And if a equals to 1, then we have no coefficient in front of the x squared. So that's relatively easy to factorize. So let's say I give you, for example, x squared. If I give you something like x squared plus 5x plus 6, well, this is pretty easy to factorize since we know that 3 times 2 is 6 and 3 plus 2 is 5. So if you have a 1 from the coefficient for a, it's usually really easy to solve. But in this case, we have a number that's not 1 in front of the coefficient. So we want to convert this into some polynomial that does have a coefficient of 1. So in order to do that, we'll convert this p of x into a new equation. We'll call it g of x. We'll convert it into this new equation, g of x, that has coefficient of 1 for the x squared term. So this will be some x squared. The bx will stay the same, so it'll still be plus some bx. And instead, the last term will be the a times the c. So we're going to take the a and times it with the c. And we're going to get g of x equals to x squared plus bx plus a times c. And this is going to factor into some x minus k times x minus h. Okay, so that's going to factorize into some x minus k and x minus h. And the claim is that the factorization of our initial equation is simply 2x, well in this case it's not 2x, but in general it would be ax minus k multiplied by ax minus h, but we want to reduce this into the simplest form. So this may not be very clear, so we'll just work through the example with what we have of our equation. So we'll work through this example here. So, okay, perfect, okay. So in this case, we're just going to convert this into a polynomial with coefficient of 1 for the x squared term. So this will be converted into x squared minus 11x plus 18. So 2 times 9 is 18. And now we want to factorize this one. So we have two numbers that add to negative 11 and times together is positive 18. That's pretty simple. That's simply just x minus 9 and x minus 2. So we have x minus 9 and x minus 2 is the factorization of this polynomial here. And we claim that the factorization of our original equation is simply 2x minus 9 multiplied by 2x minus 2. However, we notice that 2x times 2x, that's 4x squared, not 2x squared. So remember what I was saying, to reduce anything if it has a common factor, to reduce it into a simplest form. So we know that 2x and minus 2, the common factor there is 2. So in this case, we're going to reduce that to just x minus 2. So the actual factorization is 2x minus 9 times off x minus 1. Oh, sorry, divide by 2, so x minus 1. So that will actually be our factorization for this question. And therefore, we know that x equals to 1, or therefore x equals to 9 over 2. And like for NCA, you should always plug your numbers back into the original equation to see if it makes sense. So let's try to use x equals to 1. So if x equals to 1, then this side is negative 2, and this side is negative 3. Clearly, that doesn't make sense. So x equals to 1 doesn't make any sense. I'm going to eliminate that solution since the side lengths are negative, and we know that side lengths should not be negative. If x equals to 9 over 2, then 9 over 2 minus 3, that's positive. 9 over 2 times 2 is 9. 9 minus 5 is 4. That's also positive, so we're pretty happy here. So x equals to 9 over 2 is our answer for this question, and this should be this is a merit level question for the correct answer. And you can get an achieved if you can form the quadratic equation. So forming the quadratic equation here is an achieved. Perfect. Okay, let's look at question B. Find the equation for P in terms of Q. If 9 times 3 to the power of P plus Q equals to 27 to the power of 2Q. Again, very popular level 1 question. So the thing with level 1 questions is that the numbers they give you will always be they'll be nice numbers in terms that they'll always be squares of each other. So in this case, we know that 9 is equal to 3 squared, and we know that 27 is equal to 3 cubed. So we're going to rewrite these with base 3. So we have 9 equals to 3 squared. So 3 squared times off 3 to the power of P plus Q. And that equals to, I'm going to write 27 as base 3. So 3 to the power of 3 times of 2q. So in this case, if we multiply same base, we're going to add the powers. So we know that 3 to the power of 2 plus p plus q equals to 3 to the power of 6q. And therefore, since the bases are the same, we know that the powers must be the same. So we equate the powers. So 2 plus p plus q equals to 6q. And we want an equation for p, so simply it will be p equals to 6q minus q is 5q minus a 2. So we have p equals to 5q minus 2. And that is an excellence level question. If you can get p equals to 5q minus 2. A merit grade will come by forming the linear equation. So forming a linear equation will be up to here. That's a merit. To get an achieved, if you can simplify into powers of 3 on both sides, that is an achieved grade there. Question C. Company makes plastic ducks. Total cost in P dollars of making N plastic ducks is given by the formula P equals to 2A plus B times of N, where A and B are some constants. The cost of making 140 plastic ducks is $580. and the cost of making 200 plastic ducks is $640. We want to calculate the cost of making 300 plastic ducks. Okay, so for this question, it's simply a simultaneous equations here. So we have 580 that equals to 2 times of A plus 140B. And we know that 640 is equal to 2A plus of 200B. And we can eliminate the 2A by subtracting these two equations. So we have 640 minus 580. That equals to 2A minus 2A plus 200B minus 140B. So that's 60 equals to 2A minus 2A is 0. So we have 60 equals to 60B. Divide both sides by 60. So B equals to 1. So therefore, we know B equals to 1. So therefore, we can find the A value. So we have 580 equals to 2A plus 140. 150 minus 140 is 440. That equals to 2A. Therefore, A is equal to 220. And now we can substitute 300 into the equation to find the cost of making 300 plastic ducks. So P is equal to 220 times of 2 plus of B times of N. So that's 300 multiplied by 1. So that is equal to 440 plus 300. And that is equal to $740. And that is the final answer for this question. And if you can get the correct answer of $740, you'll get a merit grade. And to get an achieved grade, if you can form both equations, you can get an achieved. So that's an achieved there. Question D. Show that if you add the squares of 3 consecutive even numbers, then subtract 2, the result is a multiple of 2. So we can write any general even number. We can write an even number as we say that n is equal. No, we cannot use n. Probably use p. We can say that for any even number, we can say that p equals to 2 times of n. So therefore, 3 consecutive even numbers would be p equals to 2n. We have 2n plus 2, and we have 2n plus 4. So this will be the 3 consecutive even numbers for any n. Okay, for any value of n, any real value of n in the real plane. Then if we subtract 2, the result is a multiple of 2. So we need to add the squares of 3 consecutive even numbers. So we have the total, say that the expression e of x, that is going to be equal to 2n to the power of 2 plus 2n plus 2 to the power of 2 plus 2n plus 4 to the power of 2 minus 2. So therefore, this is 4n squared plus 4n squared plus of 8n plus 4 plus of 4n squared plus 16n plus 16 minus 2. It's going to simplify the equation. So now we have 12n squared. So that's 12n squared plus 24n and minus plus 20, so minus 2 is plus 18. And from now, we can't really tell anything, but we notice that 2 is a common factor for this expression. So we're going to factor out the 2. So we have 2 times of 6n squared plus 12n plus 9. And then this is just 2 times of any number. So this is like some number. Some number. We don't really care what number it is, but it's just some number multiplied by 2. And we know in general that any number multiplied by 2 is even. So in general, any number multiplied by 2 is even. Hence, e of x, or the expression, is even. And that's really all we need to do, okay? And that's an excellence level grade. You can get up to the final steps here. To get an achieved, to get a merit, you will need to simplify the quadratic expression up to this step here. That will be a merit. To get an achieved, you will need to have a correct expression for the sum of 3 consecutive even numbers. So we have e of x equals to the correct expression there. That is an achieved. That's it for question 1. So let's look at question 2. Let's look at A. So find the value of 4 plus 2 times 5x squared y minus z when x equals to negative 2, y equals to 2, z equals to 10. So for this question, it's really just a plug and chug, just chugging in the numbers and then spitting out the answer. So we have 4 plus of 2 times of 5, x is negative 2, so negative 2 whole squared, times of y, which is times 2, minus 10. Just be careful to not make any mistakes. So this is 4 plus 2 times of negative 2 squared is 4. 4 times 5 is 20, times of 2 is 40. 40 minus 10 is 30. So we have 30 in here. So 30 times 2 is 60. 60 plus 4 is 64. And this is a achieved grade there. Question B. Solve the equation 3 times of 2 to the power of 4x minus 5 equals to 24. So we notice that 24 can be rewritten as 3 times of 8, and we will be doing that. So therefore we have 3 times of 2 to the power of 4x minus 5. That equals to 3 times of 8. Divide both sides by 3, so 3 and 3 will cancel each other out. We know that 8 is equal to 2 to the power of 3, so we'll rewrite it in base 2. So we have 2 to the power of 4x minus 5 equals 2 to the power of 3. And let's equate the powers since the bases are equal. So we have 4x minus 5 equals to 3. So now 4x equals to 8, therefore x equals to 2. And that's all for this question. X equals to 2. That will be a merit level grade. And achieved will come by simplification of powers 2 on the right hand side. So this step here will net you an achieved grade there. Question C. Using the two squares drawn below, calculate how much bigger the area of the square A is bigger than the area of square B. So this is just the difference of areas. So we have the expression for area is base times height. So area equals to base times height. But for a square, we know that the base is equal to the height. So we know that A is equal to the length or the side length squared. So now we know that the expression for the difference, so we say the difference d of x is equal to 3x plus 2y squared minus 3x minus 2y squared. That would be the expression for the difference in areas. Let's expand on both of these. Let's expand. Okay, so we have 9x squared plus 12xy plus 4y squared minus 9x squared plus 4y squared minus 12xy. So in this case, the 9x squared will cancel each other out, as does the 4y squared will cancel each other out. And we have 12xy minus of 12xy, so that's a double negative, which is a positive. So we have 12xy plus of 12xy, and that is equal to 24xy. And that is, again, another merit level question. And you can get an achieved by forming a correct expression for the required value of the area difference. So if you can form a d of x equation here, that is an achieved grade. Cool, let's look at question D. Menaki wants to make a path around his swimming pool, as shown in the diagram below. The path has 3 rectangular sections. All measurements are in meters. Menaki has a concrete to make a path with a total area of 14 meters squared. We need to find the width x of the path. So first of all, we want to have an expression for the total area of the concrete. So the total area of the concrete, we can split into 3 significant sections. So if we can split it into 3 rectangles, and we know that the area of a rectangle is given by area equals to base times of some height. So the area will be this total sum. So sum, probably shouldn't use that. Just use English. So it'll be sum of all rectangle areas. So sum of the rectangle areas. And that is going to be equal to this rectangle here. We'll put this in red. So this rectangle here. We have this rectangle here. And we have this rectangle here. So the area is going to be equal to 3 times of x. That's going to be the blue rectangle. And we're going to have the red rectangle, which is going to be 5x times of x, which is 5x squared. Okay, and we're going to have the green area, which is going to be x, which is the length multiplied by the height, which is 16, minus of x on this side and x on this side. So it'll be 16 minus 2x. So this will be 16 minus 2x multiplied by x. And now we can expand this expressions. So we have 3x plus 5x squared plus of 16x minus 2x squared. Okay, and we know that this is equal to 14. So we have negative 2x squared plus 5x squared, which is positive 3x squared. We'll just write it in. So positive 3x squared plus 19x minus 14 equals to 0. And again, we can use the same trick I mentioned in question 1. I'm going to convert this into a polynomial with degree 1, with coefficient of 1 from the x squared term. So we have x squared plus 19x, and 3 times negative 14 is negative 42. So now we want to solve this first degree polynomial. So two numbers that multiply to negative 42 and add to 19. So I am thinking 14, 3, 21 and 2. So we have 21 and 2. So we have x plus 21 and x minus 2. So in this case, these two numbers multiply to negative 42 and add to 19. So the factored polynomial is going to be 3x plus of 21 multiplied by 3x minus 2. And we want to reduce into the simplest term. So in this first bracket here, the common factor is 3. So this will be reduced to x plus 7. There's no common whole factor for 3x minus 2, so we'll just write it as is. And this will be the factored expression of our polynomial. So we have x plus 7 and 3x minus 2. So this will give us solutions of x equals to negative 7 and x equals to 2 over 3. We know that x equals to negative 7 is not correct because it is a negative, or give a negative value for the length of the pool. And that doesn't make any sense geometrically, so we're going to reject that solution. So the answer is x equals to 2 over 3. We can get an excellence level grade for this correct answer here. To get a merit level grade, we want to simplify to a quadratic equation equal to 0. So if you can get up to this step here, that is a merit level grade. And to get an achieved, if you can form an correct expression for the total area, that is an achieved grade there. Alright, let's look at question E. The number of small squares used in the nth shape of a pattern is given by n squared minus 2. Show that the difference in the number of small squares used between two consecutive odd number shapes is always divisible by 4. So in this case, we're going to say that any odd number can be rewritten as odd number is equal to 2n plus of 1. As we know that 2n is always an even number, and any one deviation from an even number is an odd number. Similarly, we can say that the next consecutive number can either be 2n plus 3 or 2n minus 1. It doesn't really matter which one you'll use. You'll get the same conclusion either way. For the purpose of this question, I'm just going to choose 2n minus 1, but there's no reason to not choose 2n plus 3. It's the exact same. It's just random choice. I will choose 2n minus 1. So we know that the expression is going to be n squared minus 2. So it will be 2n plus 1 squared minus 2 plus of, the difference in the number, The difference in the number of small squares used between two consecutive odd number shapes. So that will be a negative 2n minus 1 squared minus 2. So now we're going to expand. So we have 4n squared plus 4n plus of 1 minus 2 minus of 4n squared minus 4n plus 1 minus 2. So in this case, we will have 4n squared minus 4n squared. That's going to cancel each other out. We're going to have 4n minus of negative 4n. So that will be 4n plus of 1 minus 2. Minus 2 and 4n plus 1 minus 2 plus, plus 4n there. So double negative is a positive, so just apologies for that. So double negative is a positive, so plus 4n minus 1 plus 2. So just double check that I don't make any silly mistakes. So we have negative 2 and negative 2 cancel each other out. Plus 1 and negative 1 will cancel each other out. This will give us an expression of 8n. And this can be rewritten as 4 times of 2n. So therefore, since 4 is a common factor of this expression, therefore this expression is divisible by 4. So factor of 4, which directly implies that this expression or this difference is divisible by 4. And that's all we need for this question, and this is an excellence level question here for a correct answer. To get a merit, if you can correctly simplify to an expression without any brackets, that will be a merit. So if you can get up to 8n without any explanation, that is a merit. If you can get an achieved, if you can form a correct expression for the difference between successive odd number shapes. So if you can form this expression here, e of x here, that is an achieved level grade. Moving on to question 3. The rectangle and the square shown below have the same perimeter as each other. Find the value of x. So we're just going to find the expression of the perimeter for the square and that for the rectangle. So for the rectangle, we have 3x plus 2 multiplied by 2, since we have both two sides of the rectangle, plus of 2 times of 2x minus 5. That equals to 6x plus 4 plus 4x minus 10. For the square, we have the perimeter is equal to 6 times 4. So that's 6 times 4 is 24. And we know that the rectangle is equal to the square. So 24 is equal to 10x minus 6. So 30 equals to 10 times of x. And therefore, we know that x is equal to 3. And this is an achieved level question there. Alright, we're going to simplify as far as possible. We have 9x squared minus 4 divided by 15x squared minus 13x plus 2. So for this question, we're going to factor the numerator. So the numerator is the difference of squares. We have 3x squared plus 2 and 3, not squared, it's just 3x. We have 3x plus 2 and 3x minus 2 divided by a factorization of the denominator. So we just leave it as 15x squared minus 13x plus 2. We're going to use the same trick we used in the previous question, converting it into a polynomial coefficient 1 on the x squared term. So we have x squared minus 13x plus of 30. And the numbers we're going to be using here are 10 and 3. So we have x minus 10 times of x minus 3. So therefore, the factorization would be 15x minus 10 and 15x minus 3. And both of these, only one of these can be, both of these can be simplified. If you can divide the left-hand bracket by 5, you'll get 3x minus 2. And you want to divide the right-hand bracket by 5 as well. By 3, you'll get 5x minus 1. So this will be our factored expression. So we have 3x plus 2 times of 3x minus 2 divided by 3x minus 2 times of 5x minus 1. So we're going to cancel out 3x minus 2. So we're going to get 3x plus 2 over 5x minus 1. And in order to cancel these out, we know 3x minus 2 must not be 0. So x not equal to. So x not equal to 2 over 3. And also x not equal to 1 over 5. And that is because we cannot divide by 0 in mathematics. So in mathematics, we need to make sure that if we divide, it needs to not be 0. So x is not 2 over 3, and x is not 1 over 5. But you don't need the restrictions in order to get a merit. But for future reference, it's good to keep in mind that you do need restrictions, and these restrictions are important because they define whether or not, because this expression here is different to 3x plus 2 divided by 5x minus 1, since it's discontinuous at the point of x equals to 2 over 3. But 3x plus 2 over 5x minus 1 is not discontinuous at that point. So there is a very slight difference between this expression here and this expression here. They're not exactly the same thing, only because of when x equals to 2 over 3, the top expression is not defined, but for the bottom expression, it is defined, okay? So that's the main difference there, just keeping in mind. But in terms of the question, you don't need to state that to get the full mark, which is a merit. To get an achieved, if you can factorize either the numerator or the denominator, that is an achieved grade there. Let's look at question C. We want to solve the following equation: x squared plus 3x minus 10 over x squared plus 8x plus 15 equals to 3x over 2. Okay, so for this question, we can just do a cross multiplication. Okay, so we have 2 times of, Okay, that will give us a cube area. So let's see if we can simplify this expression first by factorizing first. That might give us something better to work with. So we have x, two numbers that multiply to -10 and add to 3. That will be plus 5 and -2. Divided by two numbers that times 15, which is 5 and 3. So x plus 5 and x plus 5 cancel each other out on the condition that x is not -5. So we need to check that later. Now we can cross multiply. So we have 2 times of x minus 2 equals to 3x plus times of x plus 3. So this will give us 2x minus 4 equals to 3x squared plus 9x. So 3x squared plus 7x plus 4 equals to 0. Again, we can use the same trick. We have x squared plus 7x plus 12. And this will factor to two numbers that multiply to 12 and add to 7. That would be, what would that be? That would be 3 and 4, of course. Okay. X plus 3 and x plus 4. So therefore, the solution for this question is 3x plus 3 and 3x plus 4. And we can reduce this left-hand side here to be x plus 1 times of 3x plus 4. So therefore, x equals to, or that equals to 0. We know that equals to 0. So x equals to -1 and x equals to -4 over 3. And that will be the final answer for this question, which is an excellence level grade for both the correct answers. If you can correctly rearrange the equation to a quadratic equation equal to 0, you'll get a merit. So this step here is a merit. To get an achieved, if you can factor and simplify both the numerator and denominator, you'll get an achieved. So up to this step is an achieved grade. All right, let's have a look at question D. Ihaka played basketball on Monday, Tuesday, and Wednesday. On Tuesday, he scores twice as many points as he did on Monday. On Wednesday, he scores 17 more points than he did on Monday. He scores a total of 93 points in total over the 3 days. How many points did he score on Wednesday? So for this question, we're going to let the number of points he scores on Monday be x. So let score on Monday be x. So therefore, Tuesday would be equal to 2x. So Tuesday is equal to 2x as he scores twice as many points as he did on Monday. On Wednesday, he scores 17 more points than he did on Monday. So Wednesday would be x plus 17. So therefore, the total sum of all 3 of these days is 93. So x plus 2x plus x plus 17 equals to 93. Therefore, 4x equals to 93 minus 17, which is going to be equal to 76. And 76 over 4 would be 19. So therefore, on Wednesday, he scores x plus 17 points. So on Wednesday, he scores 19 plus 17, which is 36 points. And that is a merit level grade for the correct answer. You can get an achieved by forming the correct equation to solve the problem. So forming this equation here will get you an achieved. Right, let's look at question E. The formula for the surface area A centimeters squared of a closed circular cylinder, where R is the radius in centimeters, and h is the height given in centimeters, is given by area, equals to 2 pi r times r plus h. Find the radius of a cylinder with the surface area 33 pi centimeters squared and height 9.5 centimeters. So this might seem pretty difficult, but in reality, it's just a plug and chug. So chugging this value and this value for the area and height and solving for the radius. So we have 33 pi equals to 2 pi r times of r plus 9.5. So if we divide both sides by pi, that will cancel each other out. We'll have 33 equals to 2r squared plus of 2 times 9.5, 2r times 9.5, which is 19r. So therefore, 0 equals to 2r squared plus 19r minus 33. Again, we can use our trick here. So we have r squared plus 19r minus 66 equals 0. And two numbers that add to, that times to negative 66 and add to 19, that would be 22 and 3. So we have plus 22 and r minus 3 equals to 0. So therefore, the solutions for the original equation would be 2r plus 22 and 2r minus 3, that equals to 0. And this will reduce to r plus 11 times 2r minus 3 equals to 0. So therefore, r equals to negative 11 or r equals to 3 over 2. But negative solutions are rejected since that doesn't make sense for the radius of a cylinder. So therefore, r equals to 3 over 2. That is the final answer for our question here, r equals to 3 over 2, which is an excellence level grade. To get a merit level grade for this question, you need to simplify the factor quadratic equal to 0. So if you can get up to this step here, you'll get a merit. To get an achieved, you need to simplify an equation. So getting up to number 1, so up to this step here is an achieved grade there. And that's it for this paper for the 2022 MCAT Algebra for level 1. I hope you enjoyed the video, and I hope to see you all in the next one. Thank you.